Hello students, so we are starting with our next energy conversion device, that is hydraulic turbine. So this is the second energy conversion device in unit number 1, that is introduction to energy sources and its conversions. So first we will see what is meant by hydraulic turbine. So hydraulic turbine, it is a device that converts hydraulic energy into mechanical energy. Hydraulic energy into mechanical energy. So opposite to that of pump. So in pump, we convert mechanical energy into hydraulic energy. Here we convert hydraulic energy into a mechanical energy. So hydraulic machines is there. So hydraulic machine, this is the hydraulic machine, that is the turbine, and the pump where we convert mechanical energy into hydraulic energy. So this is the pump. Pump is also called as a hydraulic machine, and turbine is also a hydraulic machine. The only difference is that in turbine we convert hydraulic energy into mechanical energy. In pump we convert mechanical energy into hydraulic energy. So hydraulic turbine are the basic prime movers which convert hydraulic energy into mechanical energy. So hydraulic energy, it is in the form of either pressure energy or it is in the form of kinetic. So the pressure energy is developed due to the head of water in case of hydroelectric power plant. So the water is stored in the dam at higher level or at high head. So the pressure energy gets developed, that is the potential energy gets developed in that dam, and after that potential energy gets converted into kinetic energy when the water is flowing through this penstock and to the turbine. So pressure energy is developed due to the head of the water in the form of potential energy and kinetic energy. And kinetic energy is developed due to the mass flow of water with some velocity. Now, the shaft of turbine, it rotates due to either impact force or due to the reaction force. So if the impact force is there, that type of turbine is called as impulse turbine. And when there is a reaction force is there, then it is called as a reaction turbine. So the shaft of hydraulic turbine rotates due to either it is impact force or because of reaction force of water on hydraulic blades. Then this shaft of hydraulic turbine is connected to the or coupled to the generator through which we can produce the electrical energy. So pumps converts mechanical energy into hydraulic energy, that is the mainly pressure energy, and the turbine converts hydraulic energy, that is mainly pressure energy or kinetic energy, into a mechanical energy. So this is about hydraulic turbine or hydraulic machine. Now there are different types or classification based on this hydraulic turbine. So first is classification based on or according to the energy available at inlet. So which type of energy is available at inlet? Based on that, they are classified into two types. One is impulse turbine and another one is reaction turbine. So if the impulse energy is available, then it is called as impulse turbine, and if reaction energy is available or reaction force is available at inlet, then it is called as a reaction turbine. So example of impulse turbine is Pelton wheel, and example of reaction turbine is Francis turbine and Kaplan turbine. Now according to the available head, they are classified into three types of turbine. One is low head turbine, medium head turbine, and high head turbine. So when the head is less than 30 meter, then that type of turbine is called as low head turbine. For example, Kaplan turbine is a low head turbine. Medium head turbine, when the head it is lies between 30 meter to 100 meter. So that type of head is that type of turbine is called as medium head turbine. So Kaplan turbine and Francis turbine, these are the example of medium head turbine. And high head turbine, when the head of water is greater than 100 meter, So that type of turbine is called as high head turbine. And the example of this high head turbine is the Pelton turbine. Similarly, according to the direction of flow of water inside the turbine, they are classified into three types. First one is tangential flow. So the direction of flow of water inside the turbine, it is tangential. So it is called as tangential flow turbine. Example is Pelton wheel. Second one is radial flow turbine. When the direction of flow of water inside the turbine, it is radial type, as like centrifugal pump. Then it is called as a radial flow type of turbine, that is a Francis turbine. And third one is axial flow type of turbine. When the direction of flow of water is axial, then it is called as axial flow turbine. Example, it is the Kaplan turbine. So we'll see these two types of turbine mainly, that is impulse turbine and reaction turbine, one by one. So first is impulse turbine. So if you see this impulse turbine, in an impulse turbine, the potential energy, that is available potential energy of water, is first converted into kinetic energy by means of nozzle. So here there is a nozzle. So by means of nozzle, the potential energy gets converted into a kinetic energy by means of this nozzle. And this kinetic energy, the high velocity jet coming out of this nozzle. So this is the high velocity jet, that is called as a jet of water. So the high velocity jet coming out of this nozzle is directly strikes on series of blades. So these are the number of blades or series of blades, or it is also called as buckets. They are fixed around the periphery of the rim of the circular disc, that is also called as a runner. So it is fixed on a runner, or that outer periphery of the runner. So because of the high velocity jet of water gets strikes on this blade, it results in change in momentum of water, and that force the blade is to move in this direction. So water gets move in this direction, or blade gets move in the direction, and because of that, the runner is rotating, which turn and rotate this disc, or it is called as a runner, by using Newton's second law of motion, that is impulse momentum theorem. So the Pelton turbine, it is a famous example of this impulse turbine. So Pelton turbine, it is a tangential flow impulse turbine. So if you see, the flow of water, that is jet of water, is along the tangent of the blade. Okay, so it is the along tangent. So it is called as a tangential flow of impulse turbine. So in which water flow along the tangent to the path of runner. So this is a runner. So at the tangential direction, the water gets flow. So at this end, the rotor is attached. So at this tangent of this runner, the jet of water gets strikes. So that type of turbine, it is called as a Pelton type of turbine, that is a Pelton wheel, or it is also called as a Pelton turbine. The water flows from reservoir or dam through the penstock, and from penstock it is flow through the nozzle. The nozzle converts the available pressure head into kinetic head. So it converts the pressure energy into kinetic energy of the water. So at dam, we have potential energy. This potential energy gets converted into pressure energy, and this pressure energy again gets converted into kinetic energy by means of nozzle. So the high velocity of water coming up from nozzle, it gets strikes on series of blades or buckets. They are mounted on the periphery of this circular disc, or it is also called as a runner. Then water flows into this bucket or a vein, Now this is a forward type of vane will be there. In case of pump, there is a backward type of vanes. Here, forward type of vanes will be. So the direction of water runner gets changes, and in this process there is a change in momentum, and that cause a force on bucket to move the runner. So after doing useful work, uh, after doing this useful work, water discharges from this Pelton well to the runner. So remaining water or water discharges through this part through the tail race. Okay. So after striking, the water is again passed from this turbine to the tail race part or river. So we'll see the different components of this Pelton wheel. So first component is a casing. So this part is casing. Second component is nozzle. So this component is a nozzle part. In that, this is the sphere by which we can increase or decrease the flow rate of velocity of the water flow. Next, we have a runner. So this part is a runner, or it is also called as uh, the rotor. And the fourth part is the braking jet. When we have to stop uh, the Pelton wheel or turbine, so the braking jet will be there. This is another type of nozzle. It will flow the water opposite to the rotation of runner. So we'll see all these parts one by one. So if you see the blades having a splitter, this part is called as a splitter, and this part is called as a notch part of the blade. So these are the blades, or it is also called as a forward types of blades will be there, buckets. Now first we will see the casing. Casing, it is a basic part of this Pelton wheel, and its function to prevent water from splashing outside and discharging of water to the tail race. So there are two function of this casing. First spacing is function is to prevent the water from splashing outside. So after striking of this blade, the water coming out will be splashing if this casing is not there. And also this casing provides the way to discharge the water to the tail race or in the rivers. So this is first part is called as a casing. Second part is a nozzle. Nozzle, the function of nozzle to convert the potential energy, or we can say pressure energy of water into an kinetic energy. So in kinetic energy, so there is a high velocity jet. It will produce because of this nozzle. So the forward and backward movement of sphere. So here a sphere. So we can do the forward motion of this sphere and backward movement of this sphere. So that will regulates the nozzle amount of water which is striking on the nozzle. So based on forward and backward movement of sphere. Now this movement of sphere, that is either forward or backward, it can be controlled either manual type or automatically by a governing mechanisms. So this is the second part, that is called as nozzle. Now we will see the next part, that is the runner. So third part is the runner. So if you see runner, so this part is called as a runner, where it is also called as a rotor, as well as it is also called as a runner. And these buckets or vanes, or we can say a series of buckets or vanes, they are attached or fixed to this rotor part. Okay, so this is the rotor part, and these are the number of buckets. So if you see, this part is called as a notch, This part is a notch part, and this part is a splitter part, splitter of the bucket. So runner consists of series of buckets. So for example, there is a, now this is a runner. So there are number of buckets are there. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 buckets or vanes are there, and they all are the forward, not these are the backward type. So backward type of buckets or vanes is in pump, and this forward type of buckets or fan in, it is in turbine. So the runner consists of series of buckets that are placed equidistantly along the periphery of circular disc. Then the bucket is of cup shaped, so it is like a cup, and it has a splitter in the middle. So this is the splitter which distribute water. When it strike on the splitter, that distribute water in a symmetry. So same amount of water gets strike in this part of the splitter and in this part of the splitter. Then there is a notch provided in the bucket on the outer side. So this is the notch provided so that the jet strikes on bucket when it comes in proper position of the jets only. So it strikes on the bucket when it follows this vertical position only. That is the tangential. Now we have next part. It is called as a braking jet. So this braking jet is used. It is also one type of small nozzle is there. So braking jet, when nozzle is closed to stop the turbine, the runner due to the inertia continues to rotate. Now if we cut the supply of this nozzle by using sphere, so because of momentum is there, the runner gets still run. So to stop this turbine from running in a short time, a small nozzle is provided which directs the flow of water jet on the back of the bucket. So at back position, it will direct or flow of water will be there or water jet will be there. And because of that, the runner will stop in short time. So this small nozzle is, that jet is known as a braking jet, and that nozzle is called as braking nozzle. So these are the parts of Pelton wheel. Now we'll see the different types, advantages of Pelton wheel and disadvantages of Pelton wheel. It is simple in construction, then it is easy for maintenance. Then intake and exhaust of water takes place at atmospheric pressure. So hence the no draft tube is required in case of this Pelton wheel. But in reaction turbine, this draft tube is required. Then in Pelton turbine, there is no cavitation problem, or we can say that is ED's formation problem. In case of pump, we have seen the ED's formation problem. So here there is no cavitation problem in case of Pelton wheel. In case of reaction turbine, there will be this cavitation problem. The overall efficiency of this Pelton turbine is high, and it can work for a low discharge also. Disadvantages is efficiency decreases very quickly with time. Then turbine size, runner, generator and powerhouse, it should be large. And the variation of operating head is difficult to control because of high head. So this type of turbine is usually applied when the head of water is above 100 meters. That is, we require high head in case of this Pelton turbine. So these are advantages and disadvantages of Pelton turbine. Now we will see the next turbine. It is the reaction turbine. So a reaction turbine, in this reaction turbine, the entire flow of water from head to tail, that is takes place in a closed conduit system. So because of this, this is not open to the atmosphere at any point of passage. It is a closed vessel. So because of this, we require a draft tube. Now in reaction turbine, entering at the runner, which exerts an impulse force, and it discharges. When it discharges, it exerts the reaction force, which is opposite to the direction of flow. And this reactive force is more than the impulsive force of reaction turbine. And because of this reaction force, the turbine gets rotating. So example of this reaction turbine, it is a Francis turbine, Kaplan turbine. These are the example. Now we will see this Francis turbine of this reaction turbine. So Francis turbine, it is a radial flow type reaction turbine. And its principle is opposite to that of the centrifugal pump. So in Francis inward flow turbine, the water enters in a spiral casing running around the runner. Then the casing cross-sectional area is gradually reduces, and so as to maintain the same velocity of water throughout the circumference of it. And when waters flow over the blades, the part of pressure energy gets converted into kinetic energy, which causes the reaction force on blade, and thereby it rotates the turbine. So when the water flow over the blades, it will convert the pressure energy into kinetic energy. And because of this kinetic energy, there will be a reaction force on blades. And because of this reaction force, the turbine rotor or runner gets rotated. So this is the example diagram for a Francis turbine. So we have a shaft is there. Then we have these are the guide vanes. Then these are the runner vanes, which is forward type. This is the scroll casing. This is the draft tube. So water leaving from this guide vanes, it gets passed through the tail rest by using the draft tube. So if you see, the construction is same as that of centrifugal pump. So only difference is that there is a backward curve. Here is there a forward curve. Vanes are there or blades are there. Now this casing is the casing with guide vanes. So this is there in case of Francis turbine. So component are scroll casing, then guide vanes. These are the guide casing. These are the scroll casing, runner, and the draft tube. So this is the draft tube which the water leaves from turbine is then passes to the tail race by using this draft tube. So first we will see the first part. It is the scroll casing. So the water supplied through penstock is fed to the spiral casing which is running around the runner. So this is the spiral casing which is running around the runner. The cross section area is of casing is gradually decreasing. So water inlet from this side. So cross section area it gets gradually decreasing along the direction of flow. So the water gets flow inside this through these guide vanes. It impact on this runner blade, and because of this, the rotor it gets rotates because of the pressure energy of this water. So the cross-section area of casing is gradually reduces along the direction of flow so that the water enters in runners at constant velocity throughout the circumference of the runner. So this is the function for scroll casing. Next first is guide vanes. So the guide vanes are allows the water to strikes on the blades without shock at the inlet. So guide vanes are fixed at a positions. However, they can swing along their own axis to change if we have to change the flow area between any two consecutive blades by means of hand or by means of a governor. Then we have a runner. So when guide vanes are open, a part of potential energy of flow is converted into kinetic energy. and remaining will be the potential energy. So some amount of part will convert potential energy into kinetic energy, and remaining energy will be potential energy. After passing through the veins, it passes over the blades of runners, and while passing through this passage, the radial component of the flow gradually changes to the axial component or axial flow, and tangential components of this flow is used for rotating the runner. So in this case, if you see the impulse, there are two types of force. One is impulsive force is also there, and there is reactive force is also there. But impulsive force is less than reactive force. So because of reactive force is very high. So because of this reactive force or a reaction force, the turbine rotor gets run or runner gets run or rotates. So that all is here. So part of potential energy is converted into a kinetic energy. So for that, it will produce impulse force, and remaining potential energy produces reaction force. And in this case, reaction force is greater than impulse force, and because of that, the rotor gets rotate because of the reaction force. So this is the runner part. Now, last part of this Francis turbine, it is the draft tube. So draft tube, it is used in reaction turbine only. It is not used in impulse turbine. So considerable fraction of available head would be wasted if turbine were placed above tail rest. So for that, we use a turbine. It should be placed as same head as that of the tail rest. If we make a turbine above the tail rest, then the head gets less. So we get lesser head. So to avoid this, we use this draft tube. So by providing turbine above the tail race level and connecting outlet of tail race level by a tube, it is called as a draft tube. And this draft tube can improve the output as well as efficiency of the turbine. So thus water after passing through the turbine is discharged to tail race through gradually expanding tube. That tube is called as a draft tube. Now this draft tube is also, I have covered this draft tube part in hydroelectric power plant also. So the most commonly used draft tube type, it is the elbow type of draft tube, and the function of draft tube is to conserve for conservation of energy and remaining at the exist of runner into the power by the turbine. So that is the function of draft tube. Now we'll see the in exam mostly there is question will be asked based on what is the difference between impulse turbine and reaction. So we'll see this difference. So in impulse turbine, only kinetic energy of water, that is the impulse force, is used to rotate the turbine. Okay. In case of reaction turbine, both kinetic energy as well as pressure energy of water, it is used to turn the turbine. So both we have an impulsive force as well as reaction force is there, and by which it will run the turbine. In impulse turbine, the water flows through the nozzle and strikes to the blades of turbine. Here, the water is guided by the guide blades and to flow it over the turbine. Here there is a nozzle, here there is a no nozzle. There is a guide blades. Now, in this impulse turbine, impulsive force is rotating turbine. In reaction turbine, reaction force on blade, it will rotate the turbine. Both impulsive and reactive force will be there, but reactive force is greater than impulsive force, and because of that, the reactive force of the blade, it allows the rotation of the turbine. Next difference point is the pressure of water remains unchanged in this impulse turbine, and it is equal to the atmospheric pressure. Similarly, in case of reaction turbine, pressure of water gets continuously decreases when it flows over the blades. So it get continuously decreasing. Next, the pressure of water is reduced in nozzle before entering the turbine. The pressure of water is decreasing while flowing over the blades. So inside this pressure is decreasing. Here pressure is decreasing before it entering with the turbine. Now next, in impulse turbine, all pressure of the water is converted into kinetic energy before it's striking to the blades. In reaction turbine, there is no change in pressure energy before the striking in turbine. Now we have another differentiation points. So next is this impulse turbine is most suitable for large water heads, that is high heads, that is more than 100 meters. This reaction turbine, it is more suitable for low water head as well as medium water head, that is between less than 30 meter or between 30 to 100. Next, impulse turbine is suitable for comparatively low water flow rates. But here in reaction turbine, we require more water flow rate. Next, in impulse turbine, there is no necessity of turbine casing because we convert the pressure energy of water into kinetic energy by means of nozzle. So there is no requirement of casing in case of impulse turbine. So in case of reaction turbine, there is a casing requirement because pressure at inlet is very high as compared to the pressure at outlet. So pressure is decreasing from inlet to outlet. So casing is provided in inlet impulse turbine only to prevent splashing of water. That is the function of casing in impulse turbine. Next, the blades are symmetrical profile in case of impulse turbine. The blades are asymmetrical profiles and having aerofoils profile of the blade in reaction turbine. Then water discharge directly from turbine to the tail race in case of impulse turbine. In reaction turbine, water discharges into a draft tube first, and from this draft tube, it will discharges to the tail race. For same power output, the size of impulse turbine is smaller, and for reaction turbine, we require a large size for same power output. Example of impulse turbine are Pelton wheel, then turbo turbine, cross flow turbine, and the example of reaction turbine are Francis turbine and Kepler. So this is all about the second energy conversion devices, that is the hydraulic turbines. It may be a impulse type of turbine or it may be a reaction type one. So in impulse time, we have seen the Pelton wheel, and in the reaction turbine, we have seen the Francis type of turbine. Okay. So this is all about this topic, that is energy conversion by using uh, turbines. So that converts your hydraulic energy into a mechanical energy. So thank you for watching this video, and also subscribes to my channel so that you will get updated videos on this subject or on this unit also. Thank you. Thank you very much.